Welcome to The Explainer. Today, we're diving into a pretty wild research project that's teaching an AI how to become a digital detective, hunting down cyber threats that are hiding in plain sight. So let's just start with this number right here. $10 billion. Yeah, you heard that right. That was the estimated damage from just one type of cyber attack in a single incident just last year. So what's behind that staggering price tag? It's something called an injection attack. It's a hugely expensive and incredibly dangerous vulnerability that, as we're about to see, researchers are now starting to fight back against using artificial intelligence. All right, let's get into the weeds here. The whole problem really starts with this one specific kind of cyber attack, and it targets the modern databases that pretty much power our entire digital world. So what exactly is a NoSQL injection attack? Well, think of it like this. An attacker figures out how to sneak their own malicious instructions into a totally normal request that gets sent to a database. And because these modern NoSQL databases are built to be super flexible, well, that exact same flexibility can be twisted and used against them to bypass security and steal really sensitive data. Okay, so you're probably thinking, wait a minute, why can't we just use the security tools we've always had? And that's a great question. The answer, it turns out, lies in how fundamentally different these new databases are from the old ones. And this slide, this right here, really nails the problem. Our old school security was built for that predictable, super organized filing cabinet on the left. But today's databases, they're much more like that folder on the right. Dynamic, flexible, it can hold anything. And the old rulebook, it just doesn't work anymore. And look, this isn't just some theoretical problem. The consequences are real, and they are massive. Even with all the standard security measures in place, these huge attacks are still breaking through, and they're costing companies, and all of us, billions. It's clear we need a new playbook. So that's the problem. It's big, it's expensive, but this is where things get really interesting. This is where the fight back begins. It all comes from a research project by Shaunak Parney and Meenal Sherdkar at Goa University, and they decided to tackle this thing head on. You know, their goal here was actually pretty brilliant in its simplicity. See, instead of just trying to build taller walls to keep the bad guys out, they thought, what if we could train a digital detective, an AI that could learn to spot a criminal just by its behavior, not by a name on a wanted list? So, how do you actually build an AI detective from scratch? Well, in this case, the researchers broke it all down into 4 key steps. Step 1, you gotta collect the evidence, right? A detective is nothing without clues. So they set up their own database and they just hammered it with hundreds of requests. Some were perfectly safe, everyday queries, and others were sneaky, malicious attacks. This whole process created a log file, which is basically the security camera footage of everything that happened. Okay, so now you've got all this raw data, but a lot of it is just noise. The next step, and this is so important, is identifying the key clues. It's a process called feature engineering. And it's kind of like telling a detective, hey, ignore the shoe color, but pay very close attention to the fingerprints. They pulled out these tiny details, like how long a request was or how much computer power it used, that could help the AI tell a threat apart from a normal user. And here's a really cool part. They didn't just bet on one detective. Nope, they held auditions for 9 different types of machine learning models. Each one has its own way of thinking, its own strategy for finding threats, and they wanted to see which one was going to be the Sherlock Holmes of the group. All right, the moment of truth. After all this setup, all this training, did it actually work? How well did this lineup of AI detectives do their job? Well, the results are pretty impressive. The best performing model, the Star Detective, achieved an overall accuracy of 84.5%. So what that means is almost 85% of the time, it could correctly look at any query and say, yep, that's safe, or whoa, that's malicious. But for security, there's another number that's maybe even more important. And that's precision. Check this out. When the AI raised a red flag and basically yelled, hey, this one's an attack, it was right 88% of the time. That is huge. It means they're not constantly chasing down false alarms, which is a massive headache for security teams. And you know what's fascinating? They found that the more clues you give the detective, the smarter it gets. Just looking at the text of the query was good, but when they added in more context, things like how the system itself was performing, the accuracy got even better. It just proves that more context makes for a better detective. So you might be thinking, okay, that's a cool university project. But this is way more than that.
This is a real glimpse into the future of how we're going to protect our most important data.
So let's boil it all down. What are the big takeaways here? First, AI can absolutely be trained to be an effective digital detective, using data that companies already have. Second, it works. It's highly accurate and precise. And third, this whole approach gives us a proactive way to hunt for threats, not just sit back and wait to block them. And at the end of the day, why does any of this matter to you? Well, it's pretty simple actually. Every single app on your phone, every website you visit, it's all running on a database. Research like this is a huge step toward making our entire digital world safer from these kinds of hidden attacks. Which leaves us with one final, kind of unsettling question. We're clearly in a technological arms race. And as we build these incredibly smart AI defenders to protect our systems, we have to wonder, are we also creating the blueprint for even smarter AI attackers?